Hello guys, the old man's back, not in the shop, known as the refrigerator, but in the office, doing a quick review. Banggood multimeter with waveform oscilloscope function, and we're doing a review on that, and it was a bit bitty, and I've got to be careful editing to get rid of all the bits and pieces that were unnecessary time. So here we go, we'll give a comment on it at the end. Okay. Initially, just to look here at a screen grab of the product web page, and then a side-by-side look at two different displays, for example. Then this is a dimension picture. I've added inch measurements for extra reference there. Then we've got a data page, some figures for you, and finally more data, which is a description of the basic features. We've got a multimeter here, and the reason I wanted to take a look at it is because it has an oscilloscope function, which is the main thing I'll probably try and concentrate on. I will unbox that in a minute, very quickly. Nobody wants too much unboxing. And assuming this will still work, this is a frequency generator that I built. Oh, I don't know, is there a date on it? Yes, I built this November 1980, and it's been sitting around doing nothing for ages, which is why it's a bit dirty. So that's what I'm going to use. Assuming it works, I've got to go through the instruction sheet, so this will probably take a while to get done, although we'll shut off video in between. We've got a set of quite nice looking test leads, fairly reasonable gauge by the feel of it. The probes have protectors, which is quite handy, and the plug-in ends also have protectors. Let's take those off. Now, some aspects of this I'm going to try and economize on time so I don't bore the hell out of you. Quite a nice little wallet to keep it in. And there's the unit itself. Let's zoom in a little bit. Now this is fairly straightforward, so I'm going to give a very quick rundown first. Rotary selector, 2 off positions. I've modified some crock clips to go on the probes to make it easier to connect to resistors and that sort of stuff. So we'll be back when we're set up for some testing. Now, I meant to mention, I forgot to show you the back of it. There's a little flap here, which is to enable it to stand up, and we'll probably use that actually, so hopefully you'll see the display. I think the display is frequency driven. It does a refresh, forget the refresh rate. I'll check that later, but anyway, we'll hopefully see that. And then underneath there is where the batteries go. 3 AA batteries. Slightly awkward to put in because of this, but no big deal. So we'll come back to that in a moment. Alright, we've got a change of plan here. That other frequency generator works just fine, but the output is too low. There's not enough gain. This is another one I have, signal generator. Slightly more useful maybe, and the output is at a level that will help me test the oscilloscope function. Let's put this up to AC volts, and you'll notice on the display, because we're on auto mode, whilst it's sitting there doing nothing, it sort of talks to itself. Right, 117 line voltage. Oh, it's varying, 116, 117, so it's below 120, and it's getting towards dark, so consumption's probably going up a bit. Now, let's just, I'm struggling here, I've got a very awkward setup. Let's go to frequency. Mains frequency 59.9, so 0.1 short of 60, so we'll accept that, I think. And then to get to oscilloscope, we've got to press there for 2 seconds. Oh, hang on, I've got to come back to there. Right, now I'm struggling to see this in the camera and what's on the screen. Now we've got to change the time base here. And I'm pressing the rel button. There we are. Okay, so that is 117 volts in. And you might be able to read that, I'm not sure. I think you might be able to see 116.9 now, and 0.59 Hertz. Alright, so that's a quick check on the mains frequency. Now we'll check some other frequencies. We're on the signal generator now. So we're coming out at 22.9 kilohertz, and if I change the time base up, time base down, down again, back up, so that's quite flexible. I've got the gain turned up fairly well on this SigGen, but I'm not getting as much amplitude as I would like, but you can see the display. Now if I go from sine to square, right, we're on square, and if I change duty cycle, you can see some changes occurring. Alright, and I go to triangle waveform now. Alright, so it's displaying whatever you put in. Triangle, square, back to sine. So basically the display is showing quite adequately. Bear in mind it is basic, but I think it's rather useful to have. I have got an old oscilloscope, an old analog unit with a vacuum tube, and it works quite well. But this is quite useful to have on hand whilst you're doing other things, I think, within its limitations, but quite handy. Right, we're on DC volts. I've just happened to have outlets on this power supply on this SigGen. So it's 15015 nominal, 15.26, and then on the other leg 15.36. Not too bad. So that was just another source of voltage which we could check. Right, so we've done DC volts, AC volts off the mains, and let's see what we can do next. So let's go on to resistance, check that out. I've got several resistors here, and you won't see the colour coding. Oh, hang on, I better put the clips on. Now these clips are a bit of a lash up. They're only just about staying on. Alright, let's come up to resistance, capacitance, continuity. See what we've got through this lot. So we're on meg. Use the select button. And we go to diode volts. Well, diode testing. And then we got continuity. I'll just check that quickly. Touching the probes, continuity. Capacitance, nanofarad. And back to ohms. As I say, I'm doing this at a very weird angle. Alright, this here is a 1 watt 10% 100 ohm. If I can get it in the darn clips. Oh dear, these clips are not holding very well. Right, it's looking now 98.6, 98.5. So I guess that's basically within 5% tolerance. Then we've got another 1 watt, and this is brown, black, black. That should be 10 ohms, shouldn't it? This is also 5% tolerance with the gold band. Sorry, these clips, hang on, I've got to do these clips again. Okay, so we've got a 10 ohm, 1 watt, 5%. Let it set up its reading. Basically 10 ohm on the money. Alright, let's go up in value. What else have we got here? I think this is, I'm trying to see the colours. We're going a bit small now. I think this should be 1 meg. Going the other end of the scale, aren't we? Let's connect this up and see what happens. One meg, 1.034, quarter watt, gold band, 5% tolerance, and so that's 2 ends of the scale we've done really, which is quite handy. What have we got here? This is red, red, yellow, 220k, 5% again, quarter watt. Let's see what it makes of that. 220.8k, pretty good. And the final one here is, what do we got here? Orange, orange, yellow, that's a 330k, isn't it? And that's 5% tolerance. 329.5. Pretty good. So we've read from basically 10 ohms up to a meg, which covers most of what matters. Now let's check a couple of capacitors and see what we get. Press the select button. Continuity, and then capacitance. And of course the display being auto refreshing, it does float a bit when it's not in use. I've got a whole bunch of capacitors here, but if I can read what the value is, it will be a miracle. This is a 33 nano, if I've read it right. So what do we got? 31.13. Not bad. So we're okay at that sort of level. What else have we got? I've got a tray full of bits here. This one is, well, this is 0.33 mic. So you'll have to do a bit of mental math here and shift the decimal point so we get a reading in nanofarads. 339.2, so I'm basically 0.33 mic, close enough. And what's another one here? We've got, if I get one of the little buggers out, this one is marked as 047 mic. So we should be seeing what, 470 nano? .455.6. That's close enough for a 470 nano, or 0.47 mic, same thing. If I try a very low capacitance electrolytic, and I haven't got many here that are low, and it doesn't go very high on the higher values, unfortunately. But I think the nanofarad range is probably the most useful. Hang on, I'm trying to watch polarity on here. The other thing, of course, which probably most people will know, if you've got larger capacitance to test, you discharge it across a resistor first. Now, what's this one going to show? 10.48. It hasn't settled yet. Oh, it's coming up to mic. 95.3 microfarads, and it's marked as 80. So pretty large tolerance on that little devil. And there's another low value one here. This is I think this is 4 mic. Sorry about all this fiddle, it takes ages to hook up to each thing to check it. What's that going to come out at? 7 and a bit. And what have we got here? Oh, let's go back. This may or may not work. Back to ohms. I just want to see what happens here. I'll tell you why, if anything does happen. This is a 1 ohm wire wound. You can see it, little green fella. .1. That's okay. So we can get down to 1 ohm. So the resistance range is quite good. And the capacitance is okay up to low micro. And diode, here we go, let's check diode for you. We've got, I can't read this, I think it's a 1N101. People who use these things will be familiar with the look of that. I think it's a 101 or the same series. Now I'm putting the positive on the plus end, the end with the bar on it, so there's no reverse conduction. And if I turn it round, we should get some forward. Ah, bugger. Doing a John Mills here. Bastard. And that's 5.5 forward voltage drop, which is pretty normal. Let's see what's next. Let's try some current checks. I've got an absolute lash up here. It's probably as well you can't see it because I can't be bothered to solder things for a temporary fix. Now, I've got a 560 ohm across the 15 volt, one half of the 15 volt supply on the signal generator, and I equals E over R, so that calculates 15 over 560. The calculator says 0267, so that's about 27 milliamps pretty much. So if we switch on and see what we get, just let it settle, leave aside the negative, doesn't matter about polarity in this instance. 27.8 milliamps. Alright, switch that off, and then we'll try another value. I've got one other here. This is red. That's a 5%. That's 2.2K. Right, let's put the power on. .8 milliamps, that's about right. The calculator said 6.81. Close enough. We'll try a high value. We're going to get a tiny little figure. 330K. I haven't done the math on this one. That's almost too small. 0.08. So that's 80 microamps. Anyway, we're getting the readings, that's what matters. Two things finally. Try and wrap this up. I haven't set up a millivolt test yet. I haven't got all the components I need out here to set up a chain of components to get a really low reading, but I've no doubt that works perfectly well. If you're measuring in circuit, you may well be looking for a millivolt reading, but I'm using rather higher levels. And the other thing, which I didn't go through in detail, and the instructions tell pretty well. You've got 100 database holdings. I've put two numbers in there. One was the 15.3 from the power supply on the signal generator, and the other one 3.36, which was off a lithium battery. And those are in database now. There's 00, 01. The next readings will be 02, 03, and that would scroll through on the select, come back on the rel. So those two up and down arrows will go through the database if you've saved data. And you can also save a waveform, I believe. I haven't checked that. I've got to the point where I've sort of almost run out of stuff to do on here. I'll press this again, by the way, and hold. Back to where we were. And when you've entered a value and you come out of the hold, you will briefly get the old value before you press hold again to clear the screen, start again. I know it sounds very complicated, but if you have one of these, it doesn't take long to get used to doing the relevant stuff. And as I said earlier, 2 off positions and a 15 minute sleep option. I don't know how long the batteries will last. Haven't had a chance to leave it switched on forever because it won't. So there you are. It's a fairly comprehensive rundown. There we are, guys. Checked out most of the functions and the overall result. Quite a good unit. And there's a link in the description below. And the coupon code, valid for I think some little while, that would bring the price down to about $40, which seems pretty good for a fairly sophisticated unit. Now, as I think I said, the oscilloscope aspect was probably what interested me most, and that works pretty well. The time base covers a wide range, from very low and up to, well, way beyond what I tested, but I suspect you could go up into quite high kilohertz range. Definition is adequate. You can see the dot pattern, but that doesn't really matter because you can still see the waveform quite nicely. The microfarad range, not quite so sure about that. Judging by the data, it doesn't actually go very high, and low microfarads will actually register on the nanofarad range, which in itself to me is the most useful when I'm checking values. Now, most of us have probably got very simple, almost throwaway multimeters, and they're adequate for some jobs, but this is a bit more sophisticated, and you've got the memory aspect as well, and a fluke it isn't, but then you'd pay a lot of money for a fluke meter. So for the average shop usage, pretty useful to have around. I'll have to do a fair amount of editing because I had a lot of fiddle on the way through, because I had a very awkward camera setup and various things were awkward, so I'm hoping editing will clean it up a bit, but forgive me if it's a little bit on the scrappy side in places. Hopefully it'll be enough to give you a good idea, and the screen grabs that I'll put at the front of the video will be the main screen of the website and a couple of shots of printed data. Alright, so check it out for yourself if you like. I think you'd find it a useful addition. I'm certainly quite impressed with it for what it is. And that's it for now. So see you sometime in the future, whenever. Take care. Thanks for watching. Bye.